Always review. Review frequently. The more you review frequently, the faster you can review because it sticks. But if you don't review, it's going to fade away. Right? It's going to slip away. So do that. Right? Seize the day. Carpe diem. Right? So seize the day. What have we done? Clues, puzzles, certainty, science. These two had really good ideas to explain and ideas about and drawings and geometry, why we see what we see and when we see it. But you still couldn't quite make it out who was right. What's right is what's really going on. So we got the heliocentric alignment, and I'm going to dip into this section just very, very lightly. Angles. If you want more, let me know. I'll tell you where to go, and we will do that. You know, it's about again finding out what's really happening. But in all of this, we're not changing just what we know, we're changing how we think. That's important. Okay, we talk about our rulers, etc. We're not just settling on belief. We're going for knowledge, but not absolute knowledge, just more and more certain knowledge. More and more certain knowledge. That's what we're after. Okay. Now, sometimes you got to go with your belief. You go to where you think your car is, right? Sometimes I forgot I parked over there, and I go over there. So I go, oh man, it's right there. So I was so certain. I acted upon it. Right? I thought it was over there. Well, I often park over there, but that was yesterday. Parked over here. Lots of stories, right? You probably have them too. So certain. I thought it was there. Wait, where's my car? Did it get stolen? Oh no, I parked over there. Belief is a little different too. I mean, that's going on knowledge of where you usually park. Anyway, let's do this. Now, again, we do know now that the idea that everything goes around us and revolves around us like a 3-year-old, it made some sense because it doesn't feel like we're moving, but we're going to put that over here for now. That's fine. That's fine. Just set that over there because we know what's really right. It's more heliocentric. We're going to get into the details of heliocentric. And so as we do, and we'll see how we came to know that. We still get to go outside and look and wonder. So where are we? We're there, 3.4 and 3.5. Let's do this. Come on over here. I got some terms in the book, written out in more detail in the book, so just quickly go into this. These can be a little tricky. Heliocentric terms, okay? Real quickly, there's opposition, conjunction, maximum elongation. There's 2 types of conjunction. There's superior conjunction and inferior conjunction. New words are always confusing. Like, what is that? Okay, we gotta play with it. Opposition means opposite. But what's opposite? Well, we are looking up and pointing at sun. Don't look right at it. And a planet. And if they're opposite, we say they're opposition. That's it. What does that mean for our heliocentric view as seen from space? What would that be like? I see it opposite here. Opposition, opposite. Sun and planet are seen opposite each other. One's there, one's there. Conjunction, con, there's that word again, Latin word, Spanish word, con, with. Sun and planet are seen with each other. There's sun, there's planet. Superior means the planet is actually farther away than sun. Inferior means the planet's actually closer than sun. You're not going to be able to tell that with your naked eye, but we got to map this. We're trying to figure this out. We don't have telescopes. We don't have anything, computers. Right? And maximum elongation is, I don't like that term, maximum angular separation between a planet and sun. That's what you want. I mean, if sun is here, really, I don't have a, all right, fine. If sun is here and a planet's here, I can't see that. Look, they're with each other, con. Here here it's inferior because the planet's closer to me. Here it's superior. Still, I can't, I don't like conjunction. I want to be farther apart so I can see this. That's the maximum angular separation. It's the best time to see a planet, and that includes when they're opposite. That's really ideal. And that's it. So let's talk about this. And again, I'll let you read. We are taking on the challenge of the ages. It's not just poetic, it's true. We're trying to connect what we see from Earth and what we would, because we can only imagine. We're not ancient shepherds anymore. We're going to be working our way up to the Renaissance where we got cool stuff happening. Right? But we're still looking. What do we see? What do we see? And then let's connect that with what you would see from space, namely this. Right? This is what you would see from space. How would that look? Top view, side view. What's going on? What do we think's going on? We won't know until we get off the planet, right? What do we think's going on? All right, let's take a look. So we don't have to make this, don't make it too hard, but you will hear these terms actually if you do any amateur astronomy or just go out and stargazing and planet gazing. The professor says, "Hey, Mars is in opposition," which it is actually right now. But close, close to opposition. You go, well, I don't know, is that good or bad? It's great. Why? Oh, because what you're going to see is sun. Which way do I have it in the book? Yeah, I got it. It's a sun would be rising, and where would the planet be? Here's, oh look, I see sun. I don't know how far away. I don't know. Hey, you. And then where the planet's going to be? It's going to be opposite. So as everything spins around, we've been talking about that, the planet's going to be setting. They're opposite each other, right? Well, that's not so good because, well, there goes the planet and here comes the sun. So better if planet is rising and sun is setting. So that's great. Just last night, in fact, a student just emailed me and said, yeah, I saw Jupiter and Saturn where you sat, but I also think I saw Mars rising because I used my phone app. Is that right? Yes. Yes. The sun was setting, Mars was coming up. In what? Opposite. Opposition. That's what you see. What's going on? What can we imagine is going on by this model? So by this model, this is the hard part. Okay? People have a hard time with this. I'm standing on Earth, and I see sun this way, and opposite. Don't worry about latitude, longitude, all that stuff. If the sun is over there, then the planet's got to be out there. Right? That's opposite from here. We're talking about what we see from Earth, unless you're an alien. Opposite. Sun, planet. There's something special about opposition too. So let's draw it. This is how people figure this out. They're going, what's going on? I don't know. Remember, we're talking about what we see. If you go over here, then no, that's not. No, it's over here. Ah, it's over here. Why? Because look, planet and sun. Again, don't overthink that drawing. There it is. Yeah, sun. They're opposite. Opposition. It's the best time to see a planet. In fact, let me make a note about that. Right, that's what you would go out and see, but this is what we think is happening. Well, we know what's happening, of course. Let me make some notes. Ooh, I think you've got some glare there that I don't like. I'm going to get rid of that glare. Yes. This is really, so, what's the angular separation between planet and Sun. Now that could be Mars, it could be Jupiter, Saturn. What's the angular separation between those lines? 180 degrees, right? Awesome. And over here, 180 degrees. Can you still see that? 180 degrees between those arrows. One way, one the other way. That's opposite, 180. There's something else special here. I'm gonna have to, I don't know, maybe I can go up here. This is the best viewing. Oh, man. I can do it over here. Let me get it over here. Best viewing when a planet's in opposition. Right? Planet's in opposition. I want to make sure I get this. One thing is in our sky, it's the farthest from Sun. You want something near Sun to look at it. So it's farthest seen from Sun. I didn't do a very, I'm surprised I didn't write this list down in the book. It doesn't look like I did. I don't know, at quick glance. So that's an omission. Oh yeah, look, can you see this? Can you check this out? Let's give me this. Look, we're gonna use this, it's important. Sunlight goes in all directions and it bounces off whatever it hits. That's an important idea. Again, it's hard because we're used to just seeing things from Earth. When it hits here, notice that half of Earth is going to be lit and half of it will be in the dark. And notice that on this spinning ball, if you're on the night side, you get to see the planet. We saw that. As sun sets, the planet's going to rise. So this is going to be seen at night. And of course, we'd rather see it at night than daytime. What other point do I want? Oh yeah. Notice that this planet, if Earth goes around or if the planet goes around, that's the closest the planet can ever be. So the closest planet can be to us. So it's close, it's night, and it's farther from Sun. I'm not done. Almost. Yeah. And then you're going to get into this. I keep saying it. Planets farther out actually go slower. Earth is going faster and passing it on the freeway. It looks like it's going backward. And so planet is seen in retrograde, all with opposition, since Earth passing planet. Just see the picture and be aware. I don't know if you can see the writing. Oh, there it is. Earth, not very clear anyway. Right? So when planet is there and we see that, as sun sets, planet rises. We would be on the night side of Earth to see it. 180 degrees. It's the closest the planet ever gets to us, so we'll see it nice and bright and big. And it is seen in retrograde. Okay, that's the most involved, cool, in a lot of ways, one. All right, what does cone mean with, what does conjunction mean? It means this. If I look up, if planet is with sun, and I look up, and here's sun, and planet is, it doesn't have to be exactly with, but it's like somewhere like that. That's conjunction. This, they're 180 degrees apart. 0 degrees apart. And again, it doesn't have to be exact, but they're with each other. That's horrible. Forget about it. It's in conjunction. Oh, look, Jupiter's in conjunction. So forget about it. I'm not going to go look at it. Well, it's going to be out all day. So planet out all day. You can see that, right? Yeah, the planet's out all night. You might make that. What's happening seen from space? Well, seen from space, that's why. Oh, you're there, you're with me. Cool. All right, so seen from space. Oh, so I'm looking here, sun, there's sun, 1 AU away, 93 million miles. Light takes 8 minutes. There's sun. Where do I see planet? Well, you got to see planet in the same direction, right? So then I got to go planet. These arrows have to be with each other, 0 degree. That's the worst viewing of planet. Best viewing of planet. Where's the planet? Well, it could be, it depends. But if it's this guy out here, right, this one, then it's going to be way out here. Right, it's way out there. If it's the outer, out here. Now, we do have 2 planets in here that are closer. And so here, too, you would see the planet, because the scale's not right. You would look and you'd see the planet with sun. But the planet is closer than sun, and that's called inferior. I called it 2A, or inferior conjunction. Still, you're going to still see them there. And then you go, okay, that's Mercury or Venus. Maybe what if it's over here? Is that better? Is that better? No. In fact, it's worser. Still, you're looking, you see it with cone, with sun, but now it's even farther, superior. Wait. See, you're not here to correct me. I called that 2B, who cares? Inf, conj, and I called that 2A, who cares? Sup, conj. Still horrible. This doesn't matter if it's here, or there. You're seeing it with sun. But, again, these are things that they keep track of. What did they know? They know what you see. But this view says this is what's going on. And then finally you go, well, then when am I supposed to, I mean, if I see Mars, Jupiter, Saturn out here in opposite sky, opposition, that's great. When am I supposed to see Venus or Mercury? When's the best time? Here? No. Here? No. Here? No. It's good. Not the best. Let's show this. So, to finish this off, and then you got these terms. That's it. Just review, repetition. You know how to do it. So a planet farther from sun, the farthest away seen, right? Seen from Earth, if there's sun, the best place for the planet to be is over here. Opposite. So that's opposition, or 180 degrees. 180 degrees in opposition. Sorry, scribbling. What about the 2 planets that are closer? Which are those? Mercury. And I expect people to remember this. And Venus. Because there's something really cool about it. You see it up here. So check this out. Get rid of this clutter if you don't mind. Where's the best position? We're talking about the position of the planet, both as seen from Earth, but also in orbit, compared to where Earth is, with let's put the Earth there. Earth could be anywhere, but the same idea holds. Let's do Mercury first, whatever. And if you don't mind, I'm going to make this a little bigger. I'm going to stretch this out a little bit, give myself some room. You'll learn the widths and the distances of the planets in Chapter 7. Mercury. MY for Mercury, whatever. And it's going to go like this. Now you're still standing on Earth. We're sitting. You still see sun. You don't point it at the scale. The picture's wrong. So straight to the left. That's sun, the orange. And again, I would not say that I'm looking at Mercury this way. I just look that way because it's a drawing. Well, that's no good. Mercury's with sun. Inferior conjunction, and that's no good. Where is it good? Well, maybe it's up here, right? Or maybe here, but check this out. Let's see if I can do this. Pretty sure I can. Let's try to see what position would give the biggest separation between Mercury and Sun. So if I look here towards Sun, let's do whatever, that way. And I'm not worried about being up here because the drawing's just basically, that's towards Sun. As Mercury orbits around, the angle between Sun, that stick, and Mercury, the colored stick, is getting bigger and bigger. Now watch. Did you see it? Can you do it? Better drawing would be better. Okay, so there. Is it there? No, because right there, notice that that's a good angle. That's good. But notice that here, it's bigger. Here, it's a smaller angle. Up there, it's bigger. Same over here. Down there, it's good. Right here, right there is good. When it's right at that position at the tip. That's good, but it's better there. Here and here are the best spots. Those are my maximum angular separation. And I'm going to give you a nice, easy to remember number. And so that is, if Sun is here, then the maximum angular separation for Mercury, that is the biggest, the farthest, the biggest angle between my sticks, is there. And really I should draw from here and there. And that is about 3/0, 30, 3/5 is what I was going to say. 3/5. But it could be closer. It could be seen in here or even with it. And then here it's even going to appear closer and closer if you do those angles. And I'll show you what that means in a second, but let's do Venus. Almost finish this out. Now Venus, right? Venus is out here, about 1/3 and then about 2/3. Inferior conjunction. Not here, but it's going to end up being here is the biggest angle. And here, not here, not here, here is going to be the biggest angle. And notice that that's a bigger angle than for Mercury. How big? About, not exactly, this, you can look up the exact number if you want, but it's hard to remember it, you know. 45 degrees, and I'll show you what this would do you. Now, from one side there to there is 10, plus a thumb is 5, 30, 45. So wherever Sun is, if you look out wherever Sun is, Mercury is always within 3/5, or if you want, 15, 30. And Venus, and it could be close, could be right on with it, but it could be as far away as that, and Venus could be as far away as 4 of those. Let's take a look here at what that looks like on Earth. You're going to go, okay, so I'm out during the day and I'm with my friend and I go, hey, there's Venus, there's Mercury. You go, where? Well, I don't see it, but I know where it is. It's got to be, Mercury's got to be within 30 degrees of sun. It could be conjunction, but the farthest it's ever going to be is out here. And Venus is within 3 of these. That's the farthest that Mercury and Venus ever get from sun. And so, if Venus is here, it'll rise before sun. Called the morning star. It's not a star, it's a planet, please. I know you could use the term star for just shiny thing, but let's make a distinction. Or if it's over here, then sun will set and you'll see it after sunset. Evening star, not a star. Evening shiny thing. Beautiful. Mercury is close, and you never get a good view, really. It can be a faint thing. It's actually quite bright, but the sky is bright because it's always near it, either at after sunset or before sunrise. Okay? So you're learning quite a lot. This is, it's a lot. But you can do this. Expand your awareness. Use your fist and thumb. And that's the picture that you get from a heliocentric view. Seen opposite the sun, yes, sun sets, there's the planet. Then later it's nice and high. With sun, yuck. The best you can do for Mercury and Venus. So seen from Earth. And this is the part they didn't know. You can't see it from space until now. They didn't know. Copernicus was going, I think this might be going on. But he wasn't first, right? People always say he's the first or often. Aristarchus, don't forget him. Right? And there's others, likely, whatever. So that's that view. Now I want to do one. How are we doing on time? It's getting a little long in the tooth, but let's. It's probably a bit, right? But you can pause, so I'm just going to keep on going. You see how important angles are? Because it's pretty hard to, you just see these dots up there and you can go, oh, there's one, I got an angle. Right? And when things get farther away, if I walk away, my 2 shoulders will appear, if you point to them, they'll get closer and closer. Car gets farther away, it looks like the lights are getting closer and closer, but they're not. Light years away, 2 dots can be very far away. Very far away, but they can appear at a very small angle, so much so that they can be on top of each other and you can't tell they're separate. Intertelescopes, not yet. We're not there. Got to finish, get to the end of chapter 3. Review. Do the exercises in the book. You've got this. Let me talk about a very important idea, and it's a pair of lines, a pair of lines, paralines, parallax. What do I mean by pair of lines? Well, just like this. If I look here from one eyeball, let me just use one eyeball, and I look at something past my pinky and past my thumb, that's about 10 degrees. Add that, that's 15, do 2 of them, that's maximum elongation for Mercury. 4 of them. There's an angle, pair of lines. But there's something else happening. Try this. If I go like this, one eye, open the other close. Let me put this at my nose, maybe, I don't know. And I'll put it in really close, really close. Now, right now I see, actually the camera behind with this eye, the camera is behind my thumb. Now, I look at it with this eye, you see here, the camera is behind the thumb right there. But now I close it and I look at it with the other eye, and now I see it with my other eye way over there. And I close this and it's back here. And my other eye's over there. And I could do that vertically and everything. But what happens when I go farther away? I look at it with my, let's start right eye, I line it up, well, it's still there. Now my left eye, oh, it hasn't shifted as much. Smaller angle. Watch here. Oops, here. Bigger angle. Smaller angle. It's called parallax. That is, if you look at it from one and then from another, you will see what's behind it shift a lot if it's close, but if it's far away, you won't see it shift very much. Do that with the treetop go. You know, one tree in front of another and go like that. And then do with your thumb. Oh, wow, it's shifting a lot. Not shifting as much. Cut off your thumb, put it on the fence over there. Not very much. It hurts really too. But and then farther and farther, and you go, oh, I can't tell. Same with stars. Same with stars. And so I have an exercise in the book, exercise 9. It's the only thing you're really held accountable for there in chapter 3. Drawing these lines, and I'm going to show it to you real quick so you got the idea, and then we're going to find out, discover that in fact it is heliocentric. And here we go. Then we get ourselves to the Renaissance time. Carpe diem. And go, that's Latin. At that point, we'll talk about Latin and stuff. Okay. So here's the idea. Huge. You're going to get to this. You need this in chapter 10. So get the idea now. So there's back row. So I'm going to do eyes. Here's my right eye and my left eye. Whatever. There's a nose. Whatever. I don't know. Anyway, those are eyes. It's a nose. And what am I going to look at? I'm going to look at a thumb. Or anything. And I'm going to look at that object when it's, or I can look at two objects. It doesn't matter. I'm looking at object A, maybe star A. And object B. Right? Key idea here. When I looked at A, I close my left eye and I look at A. And I can keep on going until I see a tree or a car or whatever. Now I close my right eye and look at it with my left eye. It's a parallax. Parallax. Right? Until I hit something. Now I do that with B. And if it's farther away, notice that the angle between seeing it with my right eye and my left eye, it doesn't shift as much. Try it. Shifts a lot, doesn't shift much. Shifts compared to what? The background. The stuff that's so far away that when you do that, it doesn't really shift. It's hard to tell. Telescope, you can see the shift more. And so what we call that is the background. The background that's too distant to shift. And so what you see here on this background, distant stars, close stars in the galaxy, distant stars in the galaxy, yeah. When I see it from over here, I see A over here. And then when I see it from over here, I see A over there. That shifts a lot. But when I look at B, since it's farther away from me, this will give us a way to see how far things are away. Then B is here and B is here. Parallax, just an introduction. Make sure you're comfortable with it. Just walk around going like this all the time. And, don't worry about what people are saying about you. That's really all you need. And then if you do that, then we are going to be going on to 3.6, 3.7, 3.8. 3.9 is just a quick little thing. So we're going to get into some stuff, and it's pretty cool. And I'll do that another day. Oh, no. Oh, my goodness. Sorry. You were hating me, weren't you? You were looking at the book. I'm sure you were looking at the book. Ah. All right. I drew a line here. For my right eye, left eye closed, I see it A out here, and there's whatever is in the background. And then with my left eye, I see A here. Something farther away, right eye, left eye. And what I'd see compared to the background, the wall or the trees or the distant stars in my galaxy, the close stars in my galaxy, I'm not going to see that. I'm not going to be able to do that with my eyes. You can't do that. Anyway, less shift if it's farther away. Gets farther and farther and farther, less and less shift until you can't tell it shifts anymore. You get that. But it's closer, it's going to shift more. Sorry about that. Parallax, important tool. We're going to use it later. This is just an introduction. All right. Okay, gotcha.